Welcome to another episode of. Sorry, I went in too strong there, and I felt like I couldn't sustain it, so I'm backing out. Let's maybe start softer, and we can build up from there.
Start softer. Hello. Hi.
Hello. Welcome to another edition of OTMT with me, Jake Archibald,
and me, Surma.
Excellent. Okay.
Welcome to the most mindful podcast in web development.
Oh, it's a little bit NPR now, isn't it?
Yeah.
We need to pick it up from here. Should say thank you to Shopify for letting us do this and hosting it and that kind of stuff. Thank you very much.
Thank you. Appreciate it.
So, I was in Newcastle recently, visiting some friends, and I did something I've been wanting to do for a while. I did the Chris Jericho triangle. Have you heard of this? You familiar with the Chris?
No, I'm assuming it's not a musical instrument?
No. Chris Jericho is a Canadian wrestler. He was in the WWF when I was a teenager, and then obviously WWE afterwards.
You say obviously. I don't even know what those letters stand for, but I'm guessing it's different wrestling leagues?
The World Wrestling Federation was the WWF, and then they had a bit of a dispute with the World Wildlife Fund, and I assume they lost.
Was the dispute real, or was it just them acting?
Yeah, no, there was a cage match, but the problem is, like, the WWF, as in the wildlife one, they brought tigers and bears, and man, like, they were just not.
Many people died.
So much blood, and now the Wrestling Federation are called WWE. Instead, and that was many years ago.
And the E stands for?
Entertainment. Come on.
World Wrestling Entertainment. It kind of gives it away. I thought the whole point. I remember when I went to school, like primary school, I don't think it was particularly popular in Germany, wrestling overall, but it was like, it's all just acting, and other people were like, no, it's not, it's real, look at them, they're bleeding, and it's just like big mystery and conspiracy on the primary school playground.
At school, I remember being sort of made fun of for watching wrestling by a bunch of girls who were really into, like, boy bands, like they were really into Westlife, and I was proud of my.
Well, clearly, people in glass houses.
Well, that was my response. I was like, well, what's the difference between a wrestling fan and a Westlife fan? The wrestling fan knows it's fake. I was quite pleased with myself. But yeah, no, we knew it was just soap opera, Anyway, Chris Jericho Triangle. This is, I guess a good few years now ago, Chris Jericho visited Newcastle. And he posted on Instagram, great day wandering around beautiful, #Newcastle, getting ready for the sold out show. And he posted 3 pictures of his, wandering around beautiful Newcastle. And so I wanted to walk in his footsteps, and I went to the same 3 places and took the same 3 photos of myself, and it was
Were they just 3 different sides of the same building? Just basically
all 3 photos were within a 10-meter radius of each other.
No, oh, really? I thought I was just being
not just that.
That's outside
the Weatherspoons.
Well, I mean, that's right up your street.
Yeah. Well, I don't know.
Did you have an honorary pint in each Weatherspoon?
No. One Weatherspoon. Look, they're all in front of the same Weatherspoons. Like,
okay, let me do it again. Did you have 3 honorary pints in Weatherspoons?
No, I did have 1, though. And how would you explain Weatherspoons to international listeners?
Like, the simple way to put it is a pub chain. If you want to go deeper into it, it's owned by a bigot.
Oh, yes.
And technically, you should not be giving them money.
I would say it's like the McDonald's of pubs.
Yeah, that's a good way to put it.
And in the same way that they are both kind of like figureheaded by a clown. Yeah, Tim Spoon, who owns Weatherspoons, is a bit of a wolf. Yeah, bit of a problem.
That name, you really don't have much choice in life, I feel like.
Oh, that's not his real name. I can't remember his real name, but he looks a little, well, and I'm stealing a joke here. He looks a bit like a Lino from the Thundercats. It was if Lino had a racist uncle, he looks like. We'll put a link. We'll put a link to a picture of. I think it's Tim Martin, but I don't know. Tim Spoon.
I like Tim Spoon. I think I prefer that. He shall henceforth be known. We've probably mentioned this before, but we have the inverse law of effort. The more effort you put into a blog post, a library, or anything really, the less people are going to give a shit and understand what it's about. And if you do a quick throwaway article, tweet, mini hack library, people go nuts on average. Less effort, more interest.
Yes. A thing of this has been happening to me recently, that I used to blog about things I had just learned. And because I was excited, I've just learned this thing. I'm excited about learning this thing. And I'm going to write it down. And yeah, like very, very variable results on that. Whereas I recently have done a couple of posts where it's kind of just stuff I know from being around so long, you know? and it's now that's a thing. That's an unusual piece of entertainment that I've just been around so long to sort of know how these things started. And it kind of makes me feel very old, but you know, people have been reading them, which is nice.
That is something that many people do not have, the origins of weird attribute quirks.
Age. Yeah.
So I had this thing where I needed to scratch an itch. I've been working with a lot of WebAssembly stuff, mostly from C and Rust. And you know, in JavaScript, we have a couple of ways to figure out what a big JavaScript bundle consists of.
Oh, yes. You get those lovely little diagrams. There's plugins for Webpack and Rollup and yeah.
Yeah. Yeah, my go-to is usually Source Map Explorer, which is on NPM. And you just give it your source map. And then it gives you like I think it's called a tree map, which like, it's a rectangle and it partitions that rectangle into areas of proportional size to how much any given entity consumes. So if you have 20% is your code, 80% is React, that rectangle is going to be divided into 80% for a rectangle called React and 20% for a rectangle called your code.
Yes.
And it does this by folder structure. So there will be a big rectangle for node modules, but that in itself is going to be subdivided. And it's quite a nice way to figure out why is this JavaScript bundle 1.2 megabytes?
Historically, an amazing way to find out where all of your hard drive space is going. Like that's what these tools use, and it
true.
Works exactly the same way for a JavaScript bundle.
I feel like Source Map Explorer hasn't been maintained super well. Like over time, it seems that it's not. I wonder if it doesn't support the newer source map versions, because like there's more recent bundles, like what the Vite spits out just has like a big unknown area, but then other tools get it right. Anyway. What I needed is that, but for my WebAssembly binary, because it got bigger. And I wanted to, you know, in Rust, I just wrote my code, but I also pulled in some crates, as libraries are called in Rust. And I was like, well, I wonder if it's this or that library that is actually making this WebAssembly binary bigger. And I went on a journey to try and figure out where can I get this data. And can I somehow visualize it? And I want to tell you about it, Jake. Well, actually, I also want to tell you about source maps, because that was a whole parallel journey. But so I guess actually now that I say all this, what I want to call this episode is debugging on the web, because both of these things are related to that. But yeah, so that's what we're going to talk about. If you take a step back, you know, we have JavaScript and it gets bundled, it gets minified, it gets all kinds of...
I think your title is correct. I just don't think it's going to do well on the socials. I think we need to...
Oh, that's true.
I think we need to think of like, I looked at what was in my WebAssembly binary and I couldn't believe what I found. Something like that, right? Come on.
I could also go, I have beef with source maps.
Oh, yeah.
There you go.
So do I. No, wait, I have gravy with beef.
Oh.
But...
Maybe I should have gravy with source maps. Maybe. So I don't know which way to start, but I think I'm going to start with source maps, because I'm assuming our audience is on average slightly more familiar with their existence and what they're commonly used for. And what I learned while doing the research for this is that source maps were kind of like an ad hoc invention by an engineer at Google working on Gmail.
Oh, okay.
Gmail probably using GWT at the time or whatever, but the JavaScript in the end was compiled by Clojure compiler, which, you know, for a long time was deemed to be the strongest JavaScript optimizer tool out there until I think it was superseded. But there was a time where you would add Clojure compiler to your gulp tool chain.
And even then, like, you know, sometimes I'll say on Twitter, I'm importing a function from a file and another file is importing another function from that file. I wish bundlers were clever enough to split that out, you know, as in, you know, each function goes separately into the individual bundles. And then someone will go, actually, Clojure compiler can do it. So I still think there's lots of stuff in there that,
I think Clojure compiler is not to take away from all our bundlers and minifiers, but it's a proper compiler. Like it has a lot more of these techniques built in that we usually associate with compilers. And at the time, I think there was all kinds of stuff. You could add extra annotations and it was really quite good. But the problem was that at the time, and we were talking like 2009 here, this engineer working on Gmail was trying to debug Gmail and the JavaScript that Clojure compiler had spat out, which also, because Google at the time was already aware that every byte counts, had minified variable names, all kinds of minification tricks. Really hard to look at and debug in Firebug at the time.
Oh, wow, yeah.
So this guy just sat down and basically implemented a little thing into Clojure that would keep track of the code that's just being emitted. What does it correspond to in the original input files? And that's kind of what source maps are. Like it just gives you, for every point in your generated code, it has a way to tell you what is the position in the original source that corresponds to it. And then there's some extra bits and bob. But basically he just did this to help himself debug, and it kind of picked up steam. And here we are with source maps now being it's not a standard. It has a spec-ish that's just a Google doc that has been living for over 13 years now and has been worked on last year still. But it is kind of the de facto standard of JavaScript tooling, isn't it?
Yes. And I do think there is now an effort to do it better, right? To actually sort of take it into TC39.
Oh, is there?
Now, I'm kind of going from memory here, but I remember that being some chatter that the DevTools teams are wanting to get together. And because you know what? Source maps aren't perfect, are they? Like the amount of projects where I just go into DevTools and turn them off because I feel like I'm being lied to by DevTools, and it's like this. Look, I just pressed, skip the next line, and something else happened. You know what I mean? That's not what just happened. And I'm trying to debug this properly. I want to debug what's actually running, not what's whatever this is I'm looking at.
Exactly. So
I think there is some appetite to kind of revisit it and like solve the problems that exist and actually standardize it properly.
Yeah, I wanted to try to explain a little bit what is in a source map. On one hand, because it helped me understand what it can and cannot do, and also explain why these weird behaviors sometimes happen. So I guess the first thing we need to figure out is like, how does a browser, when you debug code, even know that a source map is available? And usually that's a special comment, I think typically at the end of the file, which is like a // hashbang, and then it says the source map URL equals, and it's a URL to the actual source map file, which typically has the same file name with .map at the end.
And it could be inline as well, right? Like inline is an option.
That's what I was going to say. It is a URL, so a data URL is completely fine, and it's not uncommon, and that's usually called an inline source map. But whatever that file is, whether it's an inline base64 encoded data URL or the other file that you actually have to fetch, that file is just a JSON file with a handful of properties, really. So what is in there? One thing I found is that Evan, who did ESBuild, also wrote a source map visualizer. This is not like a bundle analyzer to tell you this source file is consuming this many bytes in a bundle, but it actually visualizes the original source code next to the minified source code. And when you hover over a bit, it shows an arrow to where it ended up on the other side.
Oh, nice.
And you can literally see which files have been mangled together in different ways.
Oh, we'll link to that because I want to play with that.
Yeah, absolutely. That will, of course, be in the description. There's also going to be a link to the spec and to a Hacker News comment from the inventor of source maps, that Gmail engineer, which has a bit of details on the history. But yeah, it is just a JSON object, which really, it is quite straightforward, I want to say. So it has the name of the file that this source map is for. So the generated file links to the source map links to the generated file, so you just know how to map from one to the other. You have a list of the original source file names that were incorporated. That's mostly because you don't want to repeat the string multiple times later on, but just like say this is source file 1, source file 2, which makes it, make the whole source map smaller, even though they're already quite big. There is sometimes a list of symbols. This helps you unminify variable or function names. So it tells you, this function is called O in the output, but the original name was delete all files on hard drive or whatever. Like it tells you that. And then the big part is the mapping property, which is a very long string. And looking at it now, I'm surprised it's a string because it is really a two-dimensional array that's for some reason has been string encoded. I'm not sure what the reasoning behind it is. I wonder if it just compresses better. I don't know. So basically, it's a very long string. And if you were to split it by semicolon, each entry in that resulting array represents one line in the output file.
Okay.
And then each of these lines you can split by comma, which gives you an array of segments in that line. And segments are these little blobs in the output file that can be mapped to a source file. Now, I'm not going to try to explain the actual encoding, but it's a bit like UTF-8. It's called VLQ. Basically, it's just up to 5 numbers, which is like, what file is it? What line in the original source? What column in the original source? And potentially what original name for this variable. But it really just maps a point to a point. And this is one of the things I realized where things get iffy with source maps, because it doesn't really tell you the range that it maps to. So like in the generated code, you obviously just have these list of segments, and they're going to be, if you say one segment starts in column 5 and the next segment starts in column 8, you know the first segment is 3 characters long or something. But what it doesn't tell you of where it maps to, how long that is. And I think that's where the problem sometimes comes in, where you're technically setting a breakpoint in the middle of a segment, but DevTools can only set the breakpoint to the start or jump to the start. And especially with minifiers, putting multiple statements into one line and using commas instead of semicolons and potentially skipping certain things, I don't think the mapping it can express is powerful enough to handle all modern minification techniques. But I'm going to get...
Oh, interesting.
I get a bit more into that because it's a very different story in WebAssembly. That's quite interesting. So yeah, basically what the browsers do, stepping through the generated code, the minified code, is quite easy for a JavaScript engine. And then whenever it wants to figure out where it currently is, it just basically does a binary search through this mapping data and figure out what is the correct corresponding source file. And then it can either fetch the source file, or sometimes the contents of the source files are also embedded in the source map itself, which makes them even bigger. But that allows you to debug in production as well.
I think that's the more common way of doing it, right? Like I think
so, yeah.
Yeah.
I guess sometimes if you want to debug in production, it might be good to strip it because you don't necessarily want to leak your source code. But if you have the source code locally available, you can give it to DevTools so it can resolve it while debugging, while people who are out there in the world can't really deduce anything meaningful from.
I was going to say, does that actually matter? Because your minification shouldn't be a security step, but in the sort of newer world of Remix and like it's some of the React server component stuff where you have in like your database code in the same file as your client code, I guess that's where it would become potentially difficult, right?
I would agree that minification, all this stuff, is not a security primitive. But for certain things, it's obviously saying if it's on my screen, technically I can download it. But sometimes you don't want that while still allowing people to look at stuff on screen.
Right.
And so I think you just want to make it hard. And so like debugging could also like make it harder for people to actually inject code in the right place if they want to write a malicious browser extension. So I think, it's not a good protection. It's just a hurdle, but it shouldn't be it should be the only thing you do to try and keep your users safe.
Oh, but you definitely wouldn't want your server code crossing that boundary,
sure.
Which technically in a build system.
No, that's actually a good point. So there in that world, it's probably more important to do that, to not necessarily have your source maps contain the full source code of all your source files. This is already like the end of what source maps contain. So it's really just a list of segments that map to your original source. And so what Source Map Explorer does, and what I now did as well in the tool I wrote that I'm going to talk about in a little bit, you just iterate over all the segments in the generated code. You figure out how long they are by looking where does the next segment start, and then map that, like figure out what does the segment correspond to my original source. Or actually not really what, but just like which file did the segment come from.
Mm-hmm.
And so I just built a dictionary where I have counters for each source file. And when I find a segment that is 8 bytes long, I'm going to increase the counter by 8. And when I go through the entire source map, I now have a dictionary where for each file, I know how many bytes it contributed in the bundle. And now I can visualize it. So with source maps, it actually was quite easy to like build almost like a clone of Source Map Explorer.
Nice.
However, I told the story historically a bit reversed because originally, as I guess already hinted at the start, is I needed this for WebAssembly. And WebAssembly doesn't use source maps, which is now very understandable to me because it's a compile target. And most compilers already have a way to allow debugging, and that is with DWARF, which is, I guess, the de facto standard or an actual standard for debugging symbols in native binaries.
And this is across different, it's not a Rust thing, it's not a...
Yeah, so the DWARF, the spec, is very much explicitly language and architecture agnostic. So it's not just for Intel processors or ARM processors, it doesn't care, and it doesn't care about the source language. And it's been very long standing. It's now in the 5th version. And basically that is what GDB or LLDB use when you want to step through a binary. And the whole design around DWARF is that it's very quick to parse, very quick to access or to find and access the things you're looking for. It is very capable and flexible.
So presumably this is working very similar to source maps. So your binary now has a bit of extra metadata that is able to map a certain bit of binary to essentially a sort of assembly-esque kind of stuff at the end, map that to some source code.
There is a lot of similarity. DWARF actually does even more, a lot more than source maps. And it's actually not easy to wrap your head around it because of how much it needs to be able to express. And so I'm not an expert in DWARF. I started skimming the spec, but it is quite a lot. But I did learn a little bit about it while I was building my WebAssembly bundle analysis tool. And so I thought I would give a really quick summary of what is in there to just see where native land, I guess, has ended up to do these kind of debugging procedures. And I'm guessing at the time, because it was born out of an ad hoc idea, it wouldn't have made sense to use DWARF. But now that I look at it, DWARF, because it is so widespread and supported in so many compilers, there's so much tooling out there that it might actually have been beneficial to use DWARF.
Oh.
But that's, hindsight is 2020.
Well,
so
they might be looking at it again, so yeah.
Maybe. So DWARF itself is, I don't want to go too deep, but it's basically a tree data structure of what they call DIEs, debugging information entries. And those are really a bit like JavaScript objects. They have attributes, and these attributes have values. And there's a whole bunch of predefined attributes with specific meaning. But as far as I can tell, you can also add arbitrary custom attributes for certain reasons. So in the end, what you kind of get is just debugging entries, and they form kind of a graph. And I could go a bit more into it, but I think it's actually not that interesting. If you have a WebAssembly binary or actually any native binary with debugging symbol, there is a tool from LLVM. So that's, Clang, Rust compiler are all LLVM based. So usually you have this on your system called LLVM-dwarf dump. And if you give a binary to that, you can just get a big console dump, and you can kind of scroll through and see what it means. But basically each debugging entry, each of these entries in the graph, has a source name and a source file and a range or a list of ranges of where this debugging entry is occupying the binary. So it's actually a bit the other way around. You don't go through the binary and have mappings from segments to source file, but rather you have a debug entry that is like a function or a block or a variable, and it tells you all the locations in the binary where this entity is appearing in different ways.
Oh.
So for example, if there was a function called main, that would usually just have, source file, the name is main, and then probably just a start and an endpoint, because the main has been mapped to here. Then inside this main, there could, because it's a tree, there would be sub entries, whereas like in the main function I have a variable and that is used here, here, and here. And so that is already something that Dwarf can express that source maps not necessarily could, where you have this tie back to what is the same entity. And so I was like, oh cool, this looks easy enough. I'll just iterate over all the entries in this graph and count the bytes by the ranges they have. But the result was that my total byte count was a multiple of the actual file I was trying to analyze. So clearly I was double, triple, quadruple counting bytes. And that actually makes a lot of sense because we are now in compiled language land, and a bit like what Clojure did, they do a lot more than what just bundlers and minifiers mostly do. They do stuff like function inlining. So what used to be a function call, rather than doing a call, they just copy the code from the function at that place where you call the function to avoid the overhead of jumping to another function.
Ooh.
Then Rust has generics or C++ has templates. There's this thing called monomorphization or specialization where you create an instance of a generic function because you're using it with a specific type. So if I have a function called add and it takes any type, when I call it with a float and then I call it with an integer, this function will be duplicated once for floats and once for integers. So this function now exists twice, even though in the source code it only exists once.
Oh, interesting.
And then, compilers in general are allowed to like reorder and fragment.
And I guess this is a little bit like when, in Emscripten, which I presume comes from the C compilers, where you can compile for performance or you can compile for file size. And I presume that's one of the differences. Like the compile for file size is not going to do function inlining, but that is at the expense of performance.
Exactly.
Right. Okay.
Yeah, so these flags with like what you optimize for is just different optimization passes. And that's exactly it. If you optimize for size, you're saying, I'm okay having slower code if the binary is small, and let's go, okay.
Mm-hmm.
Not only am I not going to inline, but if I find the same code in different places, I'm going to create a new function and call it rather than
nice.
Leave it as it's all the, like, I don't know if that is exactly what's happening, but I would assume would be quite a trivial optimization to add to save file size. So that's what these flags usually decide which kind of passes are enabled or disabled and how are they configured. So luckily, I want to give a shout out to Gimli, which is a Rust crate to read Dwarf files, but even more so that they have an...
Oh, I get it. I get it.
Right.
Yeah, very good.
And they have an
very
example
good.
program. Like, here's how you use Gimli correctly. And an example program they have is addr to line, address to line, which you give it a Dwarf file or a binary with a Dwarf file, and you give it an address, basically a memory address of where a function or whatever is, and it tells you which source file and which line did this come from. So I was basically able to use most of that code to now iterate through all the memory addresses that the program would be loaded to in memory and figure out which source file does that come from. So now we're kind of back to the previous approach that I took with source maps, which byte corresponds to which source file. But still, it gets tricky with this monomorphization stuff, like when you create a new version of a function for a specific type, because this could be a generic function from a library, even the standard library, but now it gets instantiated for one of your types specifically. So do you attribute that to your library, your code? Do you attribute it to the core library consumer bytes?
Right.
And then after all the specialization kicks in, now optimization comes. There was a really interesting example I found. Like, imagine you have a function in your standard library to iterate over a 2D grid. Right? You give it like a 2D grid and it calls a callback for every cell in this grid. And this function, quite sensibly, could be used for making each pixel in an image brighter, but also could give each unit in a specific region more health. It is very generic and universal. But let's say that me using this function to make each pixel brighter gets inlined. So rather than calling a function and having a nested for loop in that function, now this nested for loop is in my code. And now my callback is not a callback, but it's inlined there as well. And after optimizing it, it figures out that part of my callback code is actually independent of the inner loop, because there's some pre-calculation per row that I could do.
Because it feels like we've got a similar problem in sort of JavaScript standard stuff in that, like, because of tree shaking and dead code elimination, the size of, some libraries' impact on your project can be attributed or can be impacted by the other things that are calling it, which, so you can say like, this library is 300k, but it's only 300k because it's being called by this, or it could be even be like, an import star and then an iteration over that, or something like it is actually caused the size of that to explode. Is that similar, or am I kind of way off?
Somewhat. Like, that's why I didn't find bundle phobia super useful, because it tells you this NPM package is this big. I was like, but well, there's like 3 different versions in there, and hopefully it's tree shakeable, so if I only use one function, like, that's fine. So that's why I think actually analyzing your bundle, your output, is a lot more useful as a data point. But obviously you can't say in general this library is big or this library is small, and you can't do that in native land either, because exactly that, things get removed or reordered. The problem here, just what I realized, and this is for example, I think not something that JavaScript bundlers or minifiers do. Nested loop has been inlined, my callback has been inlined, and now some of my code has been moved in between the loops, but not all of it. So what used to be a very clear call stack, I call a function, that function calls my function back. Now these codes have been interleaved. So there's not just a clear mapping of range to range, but now you have an interleaving. And DWARF can express that as well. And that's something that source maps, I don't think, would be able to, apart from the fact that I don't think this kind of optimization happens very commonly in JavaScript lands. So yeah, that was just something I found very interesting. And also, when you ask for, in this code that I've used, what is the originating source file for this range, it doesn't just give you one file. It gives you a whole list of files, because inlining may have happened. It actually does happen quite commonly. So it will say, yeah, this address has 4 source files because it was your main function, but in this specific spot, it was originally calling a different function that has been inlined, and that function also called a function that has been inlined. So you get this whole stack. So it makes it a bit unclear how you attribute the file size. For like, I just did whatever address to file decided to do, and it seems to be good enough. But it's quite interesting to look at WASM files and see that sometimes code from a different library is attributed to my code or the other way around. And it's just something you have to deal with. I don't think there's a very clear, correct answer in every case.
I had a similar problem once when I was like trying to, because a lot of these bundle analyzer things, like you're dealing in source bytes, right?
Yeah.
And sometimes, something can look really big compared to another thing, but one of them gzips really well. And that's what we really care about, because that's the bytes over the wire. To some extent, obviously gzip bombs are bad. But yeah, you get that similar attribution problem because the order of the modules in a single file, once they've been bundled together, that matters, because suddenly it's like, oh, this first one is massive and this second one is really small, but you put them the other way around, and the back reference is, it's kind of like who owns the data being back referenced, exactly. Right? It's kind of, it depends on the order.
And then, then there's stuff where the compiler has to inject stuff. It's just like in JavaScript land where, example, a pure annotation, that a function is pure if you build a library. That has no source file. That's like a compiler emitted part. So those bytes are often without any mappings, and there's similar stuff in native land as well. I know this was not really giving a good understanding of how DWARF works, but it's more like it is definitely a lot more capable. And looking back at it, I can see how DWARF would have been overkill for JavaScript. But at the same time, I do wonder, with all the tooling that already exists, maybe it would have been useful. Although I have to say, I could not find a tool that I can give a DWARF file or a binary with DWARF in it that tells me which files have contributed how many bytes to this native binary. And so I had to build that myself. Like this kind of, I guess in native land, this kind of bundle analysis isn't common because only web is a streaming platform, right? I guess the one thing that sets it apart from all other platforms. And so that's in the end what I wrote. It's called WASM Phobia, because even though I don't like bundle phobia, I thought the name was quite funny. And so I published it. Also added source map support, because that was after I was done with it, actually comparatively easy. And the fun fact is that, the WebAssembly binaries can have DWARF embedded. So you can just drag and drop a DWARF binary into WASM Phobia, but DevTools doesn't support DWARF.
Oh.
So when you debug, when you step through a WebAssembly binary, it has its own format for the name of a function. So you see sometimes the name of the function, but you don't know what the source file is for this function. And, Rust and C++ mangle function names quite excessively to encode what the module is that it came from and what the parameter types are, because in C++ you can have the function with the same name, but with different parameter types for dynamic dispatch and stuff like that. But luckily, at the time, Ingvar, who was on our Scoosh team and was a WebAssembly advocate on the Chrome DevRel team, wrote a Chrome extension that teaches DevTools about DWARF. So when you install that and you debug a WebAssembly binary, you now actually can step through your original source code.
Oh, that's good.
And when you throw an exception or something, you get an actual stack with your source files and lines rather than just random WebAssembly errors.
Oh, why is that not just in the browser? That seems essential, right? But yeah, very good.
I know, right? I don't think variable inspection works. So, in JavaScript, when you step through, you can hover over variables and see what the values are. I don't think that works because it is kind of language specific. Because like basically Dwarf tells, yeah, this is a variable, the original name is whatever, and its type is Rust : string. So unless you know what the exact data structure of Rust : string is, you won't know how to visualize that.
Of course.
But just being able to step through and figuring out where an exception is being thrown or something like that is already incredibly useful. So yeah, and I do not know why they kept it an extension and not just looped it into DevTools itself, but that just deserves a massive shout out because I didn't realize it would actually make my exceptions nicer, and that's really valuable.
At the same time, I just did a sneaky bit of searching, and source maps is now in TC39.
Oh, cool. We should link to that.
Maybe it has been for a couple of years. Yes, we will. It's stage 0, but they're definitely working on it. Like the last commit was 3 weeks ago, so it's sort of being actively worked on, which is really nice.
That's more activities than some other stage 0 proposals.
Absolutely.
Yeah, so this was my overview of what I wanted to call debugging on the web, on how does DevTools know what code to show you, and also why I guess we both have beef with source maps. And I really hope that in the standardization that they learn from where source maps are falling short and then either make something that is long lasting and doesn't have these problems, or maybe they should use DWARF. I don't know. I mean, source maps are already big. DWARF is also big. I don't think you win or lose a lot either way. And using an existing format is usually much more beneficial than inventing something new.
Oh, absolutely. It's had more hours of work put into it.
Yeah. DWARF is extremely battle tested, so I feel like it. Yeah, I don't know. I'll guess we'll see what they do.
Oh, excellent. Well, we'll link to your wasmophobia thing, which is it's a lovely little project. It is impressive because I my assumption was always like, well, once it's a binary, then your ability to really understand where things in there came from. I just assumed that was impossible now, but it's and especially on the web where we do care about those bytes.
Yeah.
A lot of the image encoders and decoders we were dealing with would have like accept PNG as an input, but we knew like we were just able to pass in the raw bytes of an image and sort of determining like, have I definitely created a build that doesn't have the PNG encoder decoder in there? Like, and I was just like, I'm going to assume because I added these flags and the bundle is now smaller that I have succeeded, but I don't know. It feels like it should have got more smaller than it did, but I don't know.
You know what? Now we could actually probably figure this out a bit more because we could.
Yeah.
Because mscript emits dwarf as well.
Oh, nice.
If you add the -g full flag, I think I have it in the README of Phasmophobia, and we could drop it in, and we could actually take a look of like, is it a PNG.header file or PNG.c file, so they still included somewhere.
Yeah.
I actually would be more confident that I can inspect what's in there and we could figure out whether there's more that we need to do. And I guess it's the same thing in native land. This kind of tree shaking is just not a requirement, not something that is being thought of when you write code, because even in Android land, right? Like whether your Android app is 8 megabytes or 12 megabytes, nobody cares. I mean, there is a limit at some point where you go like, wait, why is this app to take notes 120 megs? But if you're below a certain threshold, nobody cares really about squeezing out the last couple bytes. But on the web, it's very, very different.
It is, and I think we were both impressed, like somewhere where it did happen differently. We were both impressed by Animal Well.
Yes.
The kind of Metroidvania game, which I haven't played yet, but I've watched videos of it and it looks really good and I really want to play it. But this is like, when you get a game on the PlayStation, it's just 100 gigabytes or whatever.
Yes,
and
easily.
And if you dare install it from a CD because you think that a Blu-ray, whatever, because you think that's going to be quicker, you're still going to be hit with that 50 gigabyte update afterwards, But Animal Well is 34 megabytes. which is like for a game these days, that's smaller than Minesweeper is on Windows these days. So
that's smaller than some web apps that are out there.
Oh, many. Funny detail of it is like on the PS5, it's not 34 megabytes, it's 101 megabytes. But the theory is that, you know, when you highlight the game's icon on the PlayStation, you get like a background image shows up, which would be like, I don't know, 4K or 8K or whatever. And the theory is that's most of the size increase. So that background image that appears on the PlayStation menu is actually bigger than the game itself. Yeah, which is, you know, that is the right way around. Like there are so many websites where a video of the website ends up being smaller than the code to make it run.
It always makes me think of the demo scene.
Oh yeah.
In the mid 2000s, I think, there was this game called K-Krieger, I think, which was 100K and had, for the time, like stunning visuals, 3D graphic, and it was basically like a Doom, like a first-person shooter. And, you know, obviously the enemies were quite dumb, but like it was incredible. It was super impressive. I'm gonna link to that as well.
And things like Frontier on the Amiga, where it's seemingly the universe fit on a floppy disk somehow, and it's like there was one. I mean, maybe talked about it on the show before, but there was a few games on the Commodore 64 where they would give you a game to play while the game was being loaded, which I always thought was like, well, that's a lovely little bit of progressive loading. But there was another reason that they did that. And the reason was the hardware code on the Commodore 64 for loading data from the tape or from floppy disk into memory was bad. Like they hit a bug close to shipping the machine out. And it was like, this bug's so bad, we've got to do the whole loading thing in a different and terrible way just for it to not be buggy. And then so after it shipped, people found it's like, well, we could load in a loader that can do it better, because better ways of doing it and software were found later on. So while you were actually playing this little game, it was actually also loading its own loader, which could load the rest of the game into memory faster. Yeah, which is brilliant, isn't it? I love that.
Some of these tricks at the time, I remember, I don't know which game it was, I'll look it up, but there was a game which, again, shortly before shipping, was crashing when you finished the game, like when you beat it. And they couldn't figure out why it crashed. So, like, basically, when you finish the game, it's just like, segfault, blah, something.
Oh, yes.
And so what they did, because at the time this was possible, when they loaded the game, they would find that string in memory, like the string that contains the error message for a segfault, and overwrite it with a message, thank you for playing whatever the game was called. And they just ship it.
It was Wing Commander. I'm sure we've talked about that on the show before. Yeah, thank you for playing Wing Commander was the game. Yeah.
Brilliant. Well, then we can cut this.
I love that game as well. Nah, well, whatever. No, look. People have said like one of the things they like about the show is it's kind of like it's almost like they're just sort of down the pub with us. And if there's one thing I do down the pub, it's tell the same story over and over again. So come on, we've got to be real.
What a brilliant point to end this episode. I think we've told the same stories, so
absolutely.
Before we lose more credibility, we can call it.
Absolutely. Well, with that then, we shall say, happy next time.